Right, so pleasant good morning. Well, actually, no, it's actually good afternoon. And welcome to the NEBOSH. First time in a long time, oil and gas qualification, right? And so for those of us who know, this qualification is a limited qualification. It is not a joke, it's not pretending what would have happened. We are only allowed two batches, and this batch is basically full. When we say full, we have 18 here and we have six in Guyana. Right? And after this, I am allowed one more batch again. And for those of us who would have heard, I would have mentioned this to you all that it's again, it's nothing on our part, it's something on NEBOSH's part where they are sort of limiting the number of persons that do the qualification. That does add to the prestige of the qualification a bit. And so what I'll say is that you all are the lucky ones because you all get to be the last 40, right? The last 40 people in the region. I do have, I think, one Guyanese here which I know pretty well, right? Which is Nikisha, right? And so the last 40 people to have this qualification, right? And I think you all are very much the chosen ones, I would say, right? I remember if you look at here, NEBOSH qualifications, they're all globally recognized, and the oil and gas qualification is top-notch worldwide, right? For those who know me, well, Samuel Shadrack is my name, the head of the course provider. I do have some new students who are here. So who we are, just a long story short. So we really do offer the NEBOSH qualifications from like the beginners level to like the degree level, right? We are not a one subject school. Many of us have done other courses with us, and every I wouldn't say year because of the pandemic, but every so often we bring a new qualification to the region. This is not new to Trinidad and Tobago. It may be new to, at least not new to Guyana either, because I have done a version of it in Guyana, right? But and that has been for the last 3 years anyway. But just a long story short, we were looking at this qualification around the end of 2019 when the pandemic struck. 2020 came, 2021, 2022, and really we started to engage NEBOSH again just around 2023. And it took from November 2023 to sometime this year to sort of get the rights then and the accreditation to offer the oil and gas qualification, right? So as I mentioned, just a long story short, it's not going to be offered after next year, February. It's a limited qualification. And I think that's a good thing because it's only those of us who are here would actually get the qualification, right? So just in terms of logistics, I was saying, if possible, Kyle, Mikhail, just have the cameras on as well, if you could. And we are still about four people short because it's 18 registered students, right? So it's good to see Elizabeth, good to see Vasus. This looks like Shanice, Alim, right? Alim, Stephen, Ramluchan, of course, not seen him, but I suppose he's there. Right, and let's make a start. So the course, like I said, those who put it on, if you
Okay.
are having something to eat or whatever, you could turn it back off, but it cannot be off for the whole hour and a half. So in terms of logistics, right? Just to get straight into this, I was going to share the syllabus with you all, but I wouldn't. I'll just talk you through it. I'm going to open the PowerPoint and let's have a go at something in the PowerPoint, right? And so, right, Amara is coming in. So I think everybody's coming in now. Just give me a minute to admit them, right? I didn't see Amrish. Is Amrish in as yet? Amrish is I didn't see Amrish come in. If you hear me, we can make yourself known. Stephen, good to see you there.
Yes, sir. Afternoon time. I have a question
Afternoon.
to ask you.
Sure,
If I
sure, go ahead, yeah.
can't take it out for the whole class, it will be pre-recorded.
Yeah, we're recording right now. Yeah.
Okay,
Well,
great.
not
Because
pre-recorded, but I suppose presently recorded because I
okay,
mean I suppose once it's finished it will be pre recorded, but there is no record of this anywhere on the internet, just our class for now anyway, right?
okay, great. Because I want to work, so if I get called, I have to go.
Okay, not a problem, right? Okay, good. All right. Lauren is coming in, but seems to be having some issues. Okay, all right. Okay, all right. Let's move on, right? Okay, so what I was saying is that this course has a written exam, and I know many of us for the pandemic we have forgotten all about that even exists, right? And again, many of us here would not know that the school is not the office, right? Many of you have come to Duncan Village. That was an office that kind of got started, like a site to the school. But for many years, for decades, we have had a building in Riverside Drive, San Fernando. So I don't know if you want to write that down. Riverside Drive, San Fernando. That's where South UE is located, but the old South UE. It's where you have Wassa, if you all know where Wassa is, the Wassa station. So for more than a decade, when I say more than a decade, really more than a decade, right? We have been the main center is down there, and that would be the exam venue, right? If anybody have been there, have anybody here been there? Have Mikhail, have you been at that center? I'm trying to see who are our older students. I know
Yeah, once.
once, probably Amrish, all of you all here kind of came through the pandemic. So in the pandemic, all the courses went online, so there's no need for a physical facility, right? But this exam is on a physical facility. You would have 2 hours to get 11 questions done. Please take a note. I wouldn't mark it on screen, it's going to keep me back a bit. And the questions are pretty straightforward, right? However, you do have to study, and I would advise you all to study like during the course itself, then, right? Like today, we're going to look at a past paper. You do have studying is one thing. Studying means you have to commit certain things to memory. And I think each exam, for those of us who did the open book exam, I think each exam is kind of unique in itself. With an open book exam, you are free to look back to your notes. But with a study-based exam, you do have to put in the hours to study. So every Sunday and every Wednesday, I'm going to be encouraging you all, like, did you all learn this definition? I think this is a good thing for exam, right? And the upside to it, the upside is that they do repeat questions in the written exam. The other upside to it is those of us who did the open book exam, there is not a need for a great quantity of answers, right? The answers are pretty straightforward, like a 2-mark question, sometimes 4 answers, sometimes 6 answers. So the most of these questions go for 8 marks. If you look at the one on the slide, can you all see that one? Yeah, so most of them go for 8 marks, right? And sometimes it's 4 and 4, or 6 and 2, or 3 and 3, 6 and then 2. So it's not, like those who did the open book exam, it was so many answers to get, right? With the written exam, it's not like that, but you do have to study, right? So please take a note of this. The pass mark is 45, and after that, I'll start. It doesn't make sense say anything else, right? So just a recap, this is the NEBOSH Oil and Gas, the real one. Right? Those of us in Guyana, I would have done a version of this there, but this is the real one. There's a written exam date, and of course, I'm going back to Guyana to get part of that done as well next month. The written exam is in San Fernando. It's in Riverside Drive. There's a school there. I'll give you directions and locations as we come closer to that in the month of November, right? You all do have classes 2 days a week. I don't know if you all know that. You have classes today and you have classes on Wednesday evening. Let's see how far we can go. Today, I have looked at this PowerPoint. I would have written these PowerPoints about 4 years ago in preparation for this course, but then the pandemic struck, right? If you look at the PowerPoint, you may be seeing 2020 in it, and that is exactly what happened. Like we were ready to go, and then the pandemic came and everything kind of got on the whole anyway, right? But thank God, like I said, we have been allowed to train 40 people in the region, two batches anyway. And like I said, this batch is pretty full, pretty much more than 20. Okay, we have 18 here, and then you have 6 in Guyana, right? All right, let's make a start.
Samuel,
Those,
sorry.
yes, sure, go ahead.
Sorry. Good afternoon, everyone. I'm Sharada.
Yes, hi.
Quick question. By chance, you know when the exam would be?
No, we have to apply for it. With these are called on-demand exams, or it's not standard, like the NEBOSH certificate is standard. We have to
Right.
apply for it. Like for Guyana, I've already applied for the one in Guyana. I don't have Nikisha here, right? So Nikisha know what I'm talking about. I've already applied for the one in Guyana. I saw NEBOSH okayed it, which is good. That was the 25th of October or something. But Shada, when we are finished, it depends on if you all say you want 2 weeks, to study or whatever have you. But we would apply for it, and we'll apply for it a month before. So like a month before. Predictively
Understood.
though, we were looking at the end of November or the first week in December. Because those are like that's when NEBOSHs normally have the exams, right? Like process safety and
Understood.
stuff is the end of every month, but certificate qualifications are like the start of every month, right?
Understood. Understood. Thanks so
Yeah.
much.
Okay, good. I will let you all know, like how I just let you all know about Guyana. We normally know a month before. We have to apply for it, and it's either they okay it or they don't okay it. If they don't okay it, they'll just give you another date. We pick our date. The date is typically a Wednesday. We pick the date, but if they don't okay like one Wednesday, they will just okay the following Wednesday, right? We'll know about a month before. All right, so let's get into it. So this is it, folks, right? The NEBOSH International Technical Certificate in Oil and Gas Operation. Yes, your books have been ordered, but you know, Trinidadians and probably Guyanese are a bit different. I shouldn't say anything more, but what I could also say is that all of you all didn't come by when you all had to come by. Some of you all did, some of you all like, I won't call any names, some of you all did. Some of you all on different payment plans and stuff, right? However, I did order all the books and I do expect them this week here. I am not the delivery or the courier service, which I think is DHL. As soon as they come in the office, I'll let you all know so you can come by and pick them up once you all get through with your payments. Because I know some of you all on different plans. We have allowed it. Not everybody have even paid for the textbook, right? Just to let you know what the situation is. Behind the scenes, there's nothing that I could do. As I said, I have put all the money and I have ordered the books, whether or not you would have kept to your payment schedule or not, right? So that's the main sticking point. We were kind of waiting. Last week, Saturday was the day few people came by, then some came by, then they didn't do what we do. Like they didn't meet the quota there, right? So by this week here, I took the decision. Let's order all the books, and I did. And so your books is on the way, but you're gonna have to stick to your payment regime to sort of get your book and move on with the qualification. Remember, the catch with these courses, right? And I'm sure you all know that this is not me, this is not Cipriani, this is not Costa. This is from the UK itself. This is the real NEBOSH. We normally tell people, and you have to pay them. NEBOSH doesn't do anything unless you pay them, right? If you all didn't pay me, I had to pay them for the books. The books don't just magically appear by the office, 20 books, just appear by the door by the office. I have to pay them, right? So they don't do anything with payment. You'll keep that in mind. And we are going to kind of follow up with you because even so, they wouldn't set the exam. They wouldn't send your exam if your payments are not all in. But you do have a couple of months with it. September, October, November. Try to get that going and try to manage your fees. I think that's what we said. We have like a payment plan, but then we kind of let people choose. If you couldn't stick to that plan, you kind of choose what you wanted to do as long as you pay it off before. Well, we had to pay them to book the exam. Again, they wouldn't set an exam if they are not paid, right? NEBOSH is a global entity. That's just obvious. That doesn't need any explanation, right? But we have to say it because a lot of people think that I have the exam or I print the book, Stephen, right? That I'm printing the book in the office somewhere, right? Is the original textbook that this book is actually more than the money that some of you all paid, right? So, those are the things we don't tell you, or those are the things that sort of haunt us in the night. But we did what I had to do, and your books are ordered. I would, most likely get it by Thursday or Friday, right? So you do your
Yeah,
part and get the
I
qualification
quote money.
paid for, and you can have your exam and everything as well. Any questions for me? Those who know me know that I normally do my part, right? I do my part more than what I'm supposed to do financially, emotionally, encouragement wise, right? Past paper wise. It's really up to you all to get your thing done and the more or less get it. And I do admire you all. I was telling those who know me, I was telling some students that I cannot hold this qualification, right? I cannot hold this qualification because I have the license. So when next year when next year February reach, remember anybody in Trinidad and Guyana could do it excepted me. So I don't have it. I have the license, but at the same time, the license is one thing, but like the person that hold the license cannot do the qualification then, right? And then by next year they stopping it from the region, right? They only allow 40 people to do it. So I do admire you all and that you all are going to be the ones that have this qualification. You all can work anywhere in the world, the UK, Dubai, right? Canada. And my license, of course, expire by next year, right? But that's how it is. That's how NEBOSH have it anyway, right? Let's make a start. So we spoke about this. Those of us who know, the Shadrach Safety Institute is accredited by NEBOSH. We're also part of the Accreditation Council of Trinidad and Tobago. The list goes on. You could read that when you get some time, right? So I really want to try to read slide 70, which is a miracle for those who know me, right? So the content of and you know what takes the time is really past papers, right? So let's try to get into this, right? To explain the purpose of and procedure for investigating incidents and how the lessons learned can be used to improve health and safety in the oil and gas industry. That's very simple, right? Explain the hazards inherent in oil and gas arising from the extraction. Some of this is new knowledge, storage, and processing of raw materials and products, right? So some of that is new knowledge, right? So let's kind of get some of the easy ones out of the way. Learning from incidents, right? So the oil and gas industry generally has a good safety record. That's actually true, right? Unfortunately, from time to time, incidents occur. Sometimes, sadly, with catastrophic consequences in terms of loss of life, damage to assets, and harm to the environment. We do have some kind of world-renowned disasters like Piper Alpha, BP Deepwater Horizon, BP Texas City, and Esso Longford are all examples. Now, I do have these videos, but for those who know me, I don't like to show videos on the first day. I like to teach. And we could always come back and look at a video. I could send you the video on WhatsApp or something, right? So learning from incidents is therefore a vital part of effective accident prevention program. Let me read some slides and I'll explain what it is you're trying to tell you in a bit, right? So learning from incidents. In order to learn from incidents, maybe I could bring this up a bit bigger here for you all. Yeah, so in order to learn from incidents, we need to ensure an effective system is in place to investigate both incidents and near misses in order to determine the immediate and root causes so that proper action can be taken to prevent recurrence, right? And for those who did the certificate level, the concept here is an accidents have more than one cause. The immediate cause is like what you see. Like if you look at a plant, you look at a plant, like what would have been above the surface then, the immediate cause is what you see. So like if we talk about oil and gas and maybe there's a spill, so what was the cause of the spill? It could have been maybe what was observed could have been like a faulty valve or, like a rusted component, corrosion, etc., right? What you see is said to be the immediate causes. But like every plant, a plant just doesn't exist on the surface then. There are roots to the plant, right? So like with every plant, there are roots. And with everything that you see, there's like a root cause behind it. And this is also true for life, right? Everything that you see, there's a root cause behind it. So like if you see, like we said that it was because of corrosion, but the root cause could have been like maybe there was no supervision, right? Like nobody was inspecting the vessel, nobody was inspecting the lines on a regular basis. Because if they were then, they would have been able to pick up the corrosion, right? With a faulty valve, there was no inspection again, right? Maybe no observation. Somebody, if it was a gauger, some technician, would have been inspecting that valve like on a daily basis. They may have been able to see like the head of the valve is faulty, it's splayed, right? S-P-L-A-Y-E-D, right? So it's splayed, or maybe when the valve is closed, it's not closing fully, we're still getting oil coming through that line, we're still getting gas coming through that line. But what you would see then is like the corrosion, but the root cause of that is like a lack of inspection, lack of supervision, etc. Right? Can you think of another root cause if we stick to the valve example, like a faulty valve and a tank, something simple, a tank that sort of leaked, right? So what we see is the faulty valve, but what is another root cause of that? What's another cause of that that's kind of below the surface level?
Lack of maintenance.
Lack of maintenance. Very good. Anybody else? It have a lot of you all out in the field, yes, I know you all know. People like Stephen, Ambrish, like what is another root cause? Root causes they say are sometimes due to the management or the manufacturer. So a root cause it could have just been a faulty valve. It could have been like a valve from the manufacturer that didn't pass some quality test, or maybe it did if the quality test wasn't good. But the valve got into service and the valve itself cannot withstand the pressure or the PSI of that line anyway, right? Anybody else before we leave this one?
And chances are, when it is that we replace the valve, we did not fit the correct type of valve for the system.
Right. And that may be due to maybe lack of the type that they wanted, right? It's like some companies do that, like they the brand you wanted wasn't available. It's not in the country, but you have a line that's, you know, you have a line that's faulty. You have to change the valve, right? So you probably would have gotten an alternative supplier from China or something. And then this in itself now may not have been the correct fit anyway, right? So you did use thread seal. I have seen it, you know, these are things I know about. You did use epoxy. Yes, companies that do this in the oil and gas field, they use epoxy on the thread seal to kind of hold the valve there. But under pressure, even epoxy or resin would not withstand that level of pressure anyway, right? All right, very good. Thanks for the answers, all who took part. Let's move on a bit. Going ahead again. All right. So we have learning from the Zumba is anyway. Let me just get it out. So learning from incidents, the reason for accident investigation. So this is quite normal for everyday safety, right? So the reason for accident investigation, to identify the immediate and root causes in order to prevent recurrence of the accident, so that we could learn lessons and communicate these internally and across the industry to ultimately improve the standards of health and safety, to enable safety management systems to be improved, to demonstrate concern for the workforce. And I suppose there are others, you know, like to avoid a fine. Why you want to get an accident investigation? To show the workers that you care about them, to build the safety culture. All of these are answers anyway. Thank God, like I said, this exam is not too much in terms of the number of answers that you have to give, right? I'm moving on. I'll ask you a question again in a bit, right? So why do we want to prevent an accident? That's obvious. So we want to prevent an accident for the following reasons. To prevent unwanted and uninterrupted or unintended, impact on the safety or health of people, to prevent asset damage, loss for stakeholders, to prevent negative impact on the environment, especially where, you know, spills are concerned, for legal and regulatory compliance, to maintain the license to operate granted by a regulator, to improve safety, reliability, and effectiveness of operations, to maintain good public relations and reputation, I guess, with members of the public, right? Other stakeholders, the Regulator Enforcement Agency in the UK is known as the HSE. If this is a new course to you, if this is the first one you're doing, just take a note of that. In the UK, they don't say OSHA. So you want to kind of write that down. So if you want to say OSHA for this exam, you have to say the HSE. They also have an environmental agency, right? Which is the EPA in the UK. But who are the persons that would be interested in your accident data then? The regulators, insurance companies, coroner in the event of a death, trade unions, maybe the press or investigative journalists, although they would not necessarily be allowed complete access to your company, right? So take a look at this question. Now, I would want you to do them for me. It have 2 on the slides if we reach the slide 70, which is a miracle. But we'll probably reach it on Wednesday, right? But we reach this one. So I want you to do this really for you, right? So you can do it and type it. You would want to keep them though, right? Because remember, for those who don't know and those of us who know, the written exam, I may be careful on how I say this because I know on record, right? The written exam has a high amount of repeated questions, right? High, you know, like the open book exam don't really repeat. Every case study in the open book exam is different, but not written exams. If you did process safety, you know what I'm talking about. If you did process safety, you know what I'm talking about. It have about 20 repeated questions, right? So one of the good things about the written exam is that they will always repeat. Now you may get up to 6 repeat questions, right? And 6 8 is 48. So you can actually pass and repeat questions. So I wanted to do this one. My friend in Guyana, which is Nikisha, already did this because I taught this in Guyana already sometime last year. But you could probably do it over and I'm going to correct it. You're going to put it back in a folder for me, right? And there's something I want to explain to you all, though, but maybe it's kind of premature. I would probably come back around 2:15 and explain it, right? I'll tell you what it is, but I won't explain it yet, right? Let's have a read of this. Many oil and gas incidents have occurred in recent years. Piper Alpha, Texas City, Mumbai, India. Outline the reasons why such incidents should be investigated by the employer, right? So you could use my slide. You could use my slides when you are writing your answer, right? So the reasons for investigation, why do you want to prevent accidents, right? So why such incidents should be investigated by the employer? You want to talk about, you know, preventing recurrence, You want to talk about finding the immediate and root causes. You want to talk about the law. You want to talk about insurance companies. They are here. All right. Now, the thing to tell you though, the second party, identify two parties other than the employer who may want to investigate these types of incidents. Like I have them on the slide here, right? Trade unions, regulators, the coroner, members of the public, etc. So what I want to tell you is the verb is different. Those of us who did the open book exam, the verb is different. However, the mark scheme is still the same. Like if this is 6 marks, they want 6 answers. They want 6 reasons. So that still is the same, right? However, outline means a brief explanation. And maybe that is not too weird for those of us who did the open book exam, because outline still means about 2 to 3 lines per answer, right? Outline still means now you could get away with 2 lines. So 2 lines is good, right? So for this question, you need 6 answers, right? And each one must be about 2 to 3 lines long. So you can say something like, the reasons why incidents should be investigated by the employer includes to prevent the immediate and root causes of the accident. First up, immediate causes are those causes that are seen. Root causes are those causes that are unseen. For example, lack of supervision, lack of maintenance, first up. That may be more than 3 lines. I'm not too sure, right? I mean, I wasn't really typing it. I was just shouting it, right? But you need 6 of those. You need 6 answers to get the 6 marks. The verb identify just means 1 line. So you don't really need to explain this. When you say identify 2 parties, you say like a party that may be interested in the investigation other than the employer includes the health and safety executive in the UK. First up, it's that easy. The written exams tend to be shorter, right? So I don't know, do you want to write that down? Do you all have pens and paper? I mean, if you're doing a level 4, level 5 course based on where it's assessed, you should have some pen and paper around. Outline means a brief explanation. Brief. A brief explanation. How brief? 2 to 3 lines is good. 2.5 lines is good. 3 lines is good. Don't go more than 3 lines. Don't go more. I mean, you could go 3.5, but don't look to go out of it. Don't write a whole paragraph there. Right? Well, Vasu said the answer there, right? Tell me if you have any questions. And like I said, when you do them and put them in a folder, right? The more we do, the greater the chance you have of seeing a repeat. Imagine if you see a repeat, right? And you do this already, then you know your business fixed. So that's how they do it over on the day. You probably will get about 4 of those. I'm hoping you get more than 4, but given the fact that passive business, they see this taking time to talk about, right? Then we have to see how much we can get done, right? So for now, this slide up, we have 2 past papers. I don't know if I'll reach that other one today. We may reach it on Wednesday. But if you could even go through and find the past paper and you could actually get it done, because they're getting it done for you, right? Not for me. Tell me if you have any questions on this. See how simple, and imagine you do have to get all correct, you know. Stephen, you don't have to get all correct. I had a student, his name was Robindra, if anybody knows him. Robindra, well, when it was in the time of written exam, then he did 6 questions and he passed. 6 8 is 48. The pass mark is 45. Yeah, it is actually less stressful than the certificate exam. The only thing that's a bit stressful is that you have to pick up your book a bit and you have to study a little bit, right? But the day itself is not that bad. It's 2 hours. By 12 o'clock, you finish, right? The
Question.
exam normally starts about, yeah, go ahead, Mika, sorry.
So example question is 6 marks. Let me say you're right down 5 out of the 6 things that are correct, one out of the 6 wrong. You get the entire question wrong, or you guess gonna catch that
No,
with
you'll
5
get
marks.
5 marks. You'll get 5 marks, right? And for those of us who
Oh,
know,
well, now we in
yeah,
time,
yeah.
man.
No, there's not level 3 project, you know, the level 3 project, if you get 99, you fail. No, this is not that. For those of us who did NEBOSH level 3, you know, if you get 99 in the project, you fail. This is not that. 45 is the pass mark, right? If you put 5 answers and if 5 of them correct, you get 5 marks, right? Also, those of us who know the technique, again, like I said, some of us are past students here, like we have Vasus, we have Mikkel, we have Glenn, we have Roger, I can't remember everybody by name. You have Steven, right? So you all kind of knows when you hear me say for the new students, some of you all know how NEBOSH operate now. Like if you don't know, like it's not number A, right? Part A. If you thought about 7 reasons why, incidents should be investigated, if you say, okay, things like to develop a positive safety culture, some of you all know more, people who are more mature, right? I could call some of you all by name. Some of you all know more than, because like Vasus is in the degree, right? So some of you all know more. So like if you put 7 answers, and one of them was wrong, they will check the seventh one. If you had 1, 2, 3, 4, 5, 6, 7 answers, and let's say the second answer you had, you put something, you made up something. Because remember, it's an exam, it is not an open book thing, right? So let's say you put something like to save money, you're just making up something, right? So to save money, and NEBOSH didn't like that, but the seventh one you had, the seventh answer you had, the reason to investigate incidents would have been, to identify a trend and to prevent it from happening again. And that was the seventh answer. They will check it, and you'll still get 6 marks, right? So those of us who know that technique, if something is 6, you can put 7. If something is 5, you can put 6. If something is 2 marks, you can put 3. And if one of them was wrong, they will keep checking till they get the mark, right? It's kind of like it's kind of like Santa Claus. Santa Claus has 6 presents to give away, right? And let's say there is only, like there's 7 children, right? But he have 6 presents. So he's gonna check and make sure that 6 goes out there, right? 6 goes out even if you have 7. So it's 7 marks, sorry, 6 marks to give away. Once you have the point, you're gonna get the 6 marks anyway. All right, I'm moving on. That's Santa Claus example may have been a bad example. But anyway, moving on, right? So the importance of learning lessons from major accidents. So from accidents, lessons can be learned to avoid similar occurrences and their potential consequences. Trends can be identified to highlight current substandard practices. The importance of learning lessons to aid in the review of the current risk assessments, to determine the highest area of priority where resources may be needed. And they have here, why do we never have time and money to do the work up front, but always have the time and money to study it afterwards, right? Types of causes or failure. So we can categorize most causes of incidents as the following types of failures. We have management or system failures, and that's like the root causes, cultural failures, technical or process failures, which may be due to equipment, right? Management of system failures. So these can include well, again, this is why I guess it may be caused by management, lack of commitment by management to safety, lack of supervision. All of these are root causes. Inadequate resources provided, manpower, financial or equipment, failure to assess the risk sufficiently, mixed messages or action behavior contradict the verbal commitment to safety, right? And that's of course poor leadership, right? So they would say something like, if we have this tank to clean, then it must be gas tested before anybody goes in, but they never did any gas testing. One time to maintain the tank or to wash the tank, whatever have you. They didn't really do the gas testing, even if that is on the permit, right? So there's always mixed messages, and when you say safety is of first priority, or safety is most important, but then the workers get the idea that there was no whole watch. You just sort of send the workers into the tank, right? So lack of procedures or procedures not implemented, maintained, or followed. Equipment not maintained adequately due to lack of time, resources, or management oversight. So, actual disasters, common examples can include Piper Alpha on the 6th of July 1988, in which a series of explosions ripped through a platform, killing 167 persons in the UK North Sea. There are also other disasters. The Nipro UK chemical plant, explosion at Flixborough. I have the video for that, the actual video, not a reenactment. Left 28 dead, 36 injured, and damages up to 2 miles away. The explosion was equivalent to 45 tons of TNT. That's an interesting one. We probably look at it as the course go along. It's not really that you have to know that particular case study, but this happened around Christmas time. Speaking of that Santa Claus example, where some junior technicians were left on the site, and the senior technicians went home because it was like Christmas Eve, and a leak developed in a tank, and they did sort of bridge that leak with a pipe, something they call like a dog leg pipe. So they kind of did connect it, between two tanks, but they put it at a slant. And because of the slant, the pressure then from one tank to the other caused that, more or less to rupture and resulted in an explosion. So some actual disasters there anyway, right? So cultural failures, these include causes rooted in the organization safety culture, lack of safe working practices tolerated and condoned by all, including management. Previous near misses not reported or not seen as important. That's another thing. Sometimes you do report the near miss. I did them in Massey. And I remember one time, for those who heard me say this story, I say the same stories all the time, right? Like one time in Massey, the CEO, not the CEO, sorry, there was somebody above the CEO. Yeah, there was like a director. And I remember that morning he came and he just, like we were wasting time, and he was trying to say that we wasting time investigating incidents. Because for those of us who read this and understand this, what is a near miss? In a near miss, did anything really happen? In a near miss, was anybody injured? No. So the, the man the man came with a stack of papers and shake them. So in front of us, when I say us, was me and a director. We were investigating a near miss now, but he was saying that we were wasting time now because the papers he was shaking was actually invoices. So he was kind of showing off how much money he made for the morning, whereas we were walking around investigating an EMS. But there are some companies, I don't know if anybody understands, some companies treat near misses very important because why do you investigate near misses? Near misses is like an indicator of what could happen the next time around. The next time around, it mightn't be lucky then, right? And there are companies like Atlantic LNG in Trinidad. I do suppose the same for Guyana, that if they are near misses or even one near miss, they will send you home. They will send the whole contractor home, which they actually did. They'll send all the workers home, right? Some companies don't make joke with near misses, but some companies do because in reality, in a near miss, it's nothing really happened then, right? A pipe fell, but no one was there, right? The valve blew out, but the tank was actually empty at the point in time, right? Which probably kind of weird example, right? So, so like maybe a leak on a line, but at the point in time they were purging the line. So what leak is just water, right? So no harm done, and it wasn't oil, it wasn't the gas, it wasn't any condensate, it's just water, right? But some companies do treat that very seriously because, why did that happen? Wasn't the line maintained? What's the PSI, right? And, like what's the emergency response? Some companies do treat it seriously, but again, the heading here is cultural failures. If you fail to treat the near misses with importance, you would be setting yourself up then like for a main accident, right? Blame culture, if you all know anything about that, the blame culture is like you blame the workers, they say it's the fault of the pipe fitter, right? No, and it is. But remember what we said, an accident have more than one causes. So yes, it's the pipe fitter, but who was supervising the pipe fitter? Who inspected the work then when the job was finished, right? If you said, okay, well, it's something with a contractor with a tank or whatever have you, right? But yeah, so is the contractor probably didn't, close up all the valves for the tank. Maybe one valve was left bleeding, as they say, right? But who fault is that? I mean, yes, it's the contractor, but wasn't it your company, your supervisor supposed to check on that as well, right? And those of us who know about pre-startup safety reviews and stuff like that, right? All of that should be checked, not just by the contractor, but by your company as well. All right. So poor communication or working relationship between departments or between clients and contractors, complacency amongst the workforce, and they will be complacent if the management team is also complacent, right? Actual disasters in 1984, Union Carbide, which is an American company, by the way, Bhopal, India disaster, resulted in more than 4,000 deaths and countless injuries and diseases amongst community residents. Well, those who know this whole story, this is not the whole story, right? And I mean, just to make it short for you, the death count is much higher than this. The death count is much higher than this. Much, when I say much is much, right? Much is much. The actual death count back then, 4,000, the death count that has been done by the HSE, is about 30,000, right? Just check that difference. 4,000 to 30,000. Why such a big difference? Why the initial report said 4,000, which is not, I mean, 4,000 is not a little bit of people, but the actual death count then, as done by an independent company, said 30,000. For those of us who know, this was the slums of India. If you all have seen that movie Slumdog Millionaire, right? If you have seen the movie Slumdog Millionaire, this is there. This is in the slums of India. But if you all have seen it, I mean, if you see Slumdog Millionaire movie, if you even see the slums, not bad enough. For those of us, a lot of people in Trinidad live worse than that. I don't know if you know that. A lot of people in Trinidad live, I mean, I'm not too sure for Guyana, but a lot of people in Trinidad live worse than the slums in India. The slums in India have everything: electricity, television. People live like that, right? It's kind of like on the outskirts of Mumbai itself anyway, right? But anyway, the long and short of the story is that because of the system in India, the death count here did not include women and children. So that's why the death count is so low here, right? But the actual death count is worse than this, right? Anyway, that's not too important for the cause. It's just an actual disaster. And yes, the American company was trying to save itself and whatever have you, right? Even today, if anybody have time, even today, there are still effects of Bhopal, India, in this part of India itself. You may wonder how, but it have, right? They say the children of the people who went through this, I guess it's maybe the third generation, or maybe still the second generation, or the people that went through this, their children are being born with some birth defects. And if you all did some studies on this, if anybody kind of research this, the strange thing is that, if you're a bit differently abled, the government will give you assistance, but not in Bhopal. The government has decided not to give assistance to people in Bhopal, but leave them to be assisted by the Union Carbide American company, which they are not really assisting anyway. It's a nice study. If you get some time, you can look at that, but to tell you how things affect workers, worldwide anyway, right? All right, let's move on. Technical or process failure. So these include any equipment malfunction, for example, emergency shutdown valve that do not really shut down, gas detectors that fail to detect, blowout preventer buckles under pressure so it doesn't blow out and retains the pressure inside. If you don't know what that is, there are some tanks and valves and stuff, they are meant to blow out, but they probably will blow out to like a receiving vessel. Most of the blowout should not be to the atmosphere, right? Automatic fire doors fail to close, pressure relief valve fail to open, overfill alarm do not send signal to the control room. That's a normal thing. That is a normal thing in a lot of companies. Unless you keep inspecting these things, a lot of times these overfill valves give the wrong reading. Something maybe saying 10 feet in a tank, or not really 10 feet, if it's a big tank, right? But so maybe 8 feet of liquid in a tank when the amount of liquid in the tank is probably 9 feet, right? So these things have to be calibrated properly. All of these, would lead to technical or process failures. Technical or process failures, we have some disasters around the world. We have Chernobyl, millions relocated, 125,000 dead, estimated US 200 million in damages because of a bypass of a safety system at 100 hours on a holiday weekend. A lot of these things happen on the holiday weekend, right? Technical support absent. The learning outcome of this is after Chernobyl disaster, the authorities failed to alert the public to the leak. This is the nuclear power plant you're talking about. That's in Ukraine, by the way. For those who don't know where this is. And this radiation is still active. For those of us who know, all they did was buried it under concrete. Well, that's what they do anyway. But that's the thing about nuclear radiation. It takes, like something called the half-life, with maybe hundreds, thousands of years for it to become less radioactive then, right? So the folks at Chernobyl had known about it. They failed to alert the public. So they say a learning outcome is that if there's a disaster and it does affect members of the public, alert the public as soon as possible. The question is, do we see companies doing that in Trinidad and in Guyana when they have disasters in Naikwan, or when they have in Paria, or when they have in Guyana? Not to show the company there. Well, besides the companies, I know, but the one I think with the with the island that they are making out in Georgetown there by the Marriott, right? There was a death on that island, but they didn't inform members of the public, or is it something that they keep to themselves anyway, right? Technical and process failures. On March 23rd, 2005, an explosion in the BP oil refinery in Texas City. I again have that video, right? Texas City, Texas killed 15 workers and injured 180. It was the worst industrial accident in the US outside of the mining in a quarter century. Financial losses exceed 1.5 billion. OSHA issued the largest citation and penalty in its history, right? That's the end of the first one, 1.1. In your textbook as well, if you want, I can show you, as nobody really have a book, right? That's the first one, and that would have been the end of 1.1, right? So if you just look at something in the book, I'll just show you over the screen for now. For those who feel as if you are being robbed, it's the same thing, right? So like why investigate accidents to identify the immediate causes, to identify the underlying, the root causes of the accident, right? And they need to learn lessons. They mentioned some of the same disasters, Piper Alpha. We'll have to look at a video if you all can see it, Piper Alpha, right? But I look at them as the course go along too, did it actually have more places where we could look at those videos anyway, right? And where we could get that done. But once you get your book, like I'm hoping by Thursday, Friday, you all can start. I don't think you need your book to start. You can start with the PowerPoint, to be honest with you. They have this, they have the same accident here, right? The Deepwater Horizon in 2010, they have Piper Alpha, right? But once you get your slide, I think you're like when we mention something for exam, because you saw this as a question, like you should probably do it then, right? And try to see if you can memorize 6 reasons to investigate an accident. Two stakeholders. That may be easy for some people, right? The HSC, insurance companies, competitors, clients may be interested and stuff, right? But like I said, the answers were here, but you kind of know like what you want to zone down to then, right? Let's go to the next one. The next learning outcome is hazards inherent in the oil and gas. Sorry, I went too fast, right? Hazard inherent in the oil and gas industry. You'll see the same if you can make that out here. Hazards inherent in the oil and gas industry, right? Let's take a look at them on this slide here. I know I'm moving slower than usual, but that's how it is, right? So in 1.2, we will look at various hazardous definitions from the oil and gas industry so that you have a greater understanding of the hazardous situations and hazardous conditions. These include flashpoint, vapor density, vapor pressure, flammable toxicity, skin irritant, carcinogenic properties, upper flammability limit, lower flammability limit, right? Even though it's the first slide, folks, I have to say something here. Some of these definitions has come, right? So that's a kind of downside with the open book, sorry, with the actual exam. Like you don't know which one. But I have seen, and you would see too just now, I could open and show you if you wanted. I mean, all of these things take extra time, right? I'm not too sure what I did with the past people. Maybe you can take my word for it for now, right? But I have seen, look at paper here, right? This, I don't know if you can tell me when you can see it. Can you all see IOG 1 Management of International Oil and Gas Operational Safety? Okay. So now I have seen a bunch of them, but the point they're trying to prove to you is that they come now, right? So but just one. So once you see it, you could actually go and learn it, right? And you can try to have an idea of it. We have vapor pressure, we have vapor density. Vapor pressure, vapor density, right? I've seen all of them now. What just one? Explain what is meant or give the meaning of the term lower flammability limit. 2 marks, upper flammability limit. That's really easy, by the way. But the catch is to learn it now or have an idea of it. You might want to say everything, the lower flammability limit is like the lowest concentration of vapor and air in the correct mix that is able to, propagate a fire. Lower flammability limit. The upper flammability limit is like the highest concentration of vapor and air just remember, like anything needed to start is vapor. So like anything need to start a fire is vapor and air. The vapor of it mixed with air. I don't know if you know that. If you're gonna burn a piece of paper, right, according to the matrix, right, it's not really the paper that burn, right? It's not really the thing that burn, right? It's not really the paper that burn. But if you had to burn this paper, right, or anything, you had to heat it in such a way that it start to make a vapor. The paper itself, what causes a fire? Other than that, you're just going to see like a brown. But what causes the fire? The brown mark then, right? What causes the fire is when you heat it so sufficiently that enough vapor is produced that mixes with the air that could sustain a fire. That is what causes a fire. And the lower flammability limit is the lower concentration of that. The upper flammability limit is the highest concentration of vapor and air. That's how simple that is. But don't just, do that. But remember, like we hope they all come back, or we hope that come back. But then remember, I have others on the slide, right? So let's take a look at them anyway. So flashpoint is the lowest temperature. If you have any questions, just shout them at me, right? Yeah, vapor and oxygen. What did I say? Well, if I did say air, it's oxygen I'm talking about, right? And you'll get it from here. So the lowest temperature at which the vapor above a volatile liquid forms a combustible mixture with air, right? At the flash point, the application of a naked flame gives a momentarily flash rather than a sustained combustion, for which the temperature is too low. Liquids with a low flash point pose the greatest danger, right? So what is the flash point? You get this is the lowest temperature, the lowest heat you can apply to something then, piece of wood or whatever, piece of paper that creates a vapor that mixes with air. And of course, yes, we're really talking about oxygen because nitrogen and stuff is not really reactive, right? When we say air here, we're really talking about oxygen. But this is a set definition. That's the flash point. Flash point, if you miss it again, is that it's the lowest temperature of the vapor in the air, but it creates just a flash, a momentarily flash. It doesn't sustain a fire. The flash point, to sustain a fire, you need to keep heated, keep getting more vapor. But the point at which you see a spark, then that's called the flash point. It gives a momentary flash, but it doesn't sustain the fire, right? There's something called the fire point. Sorry, I missed that one. I guess we'll keep going with what I have here, right? Vapor density. So this defines the density of vapor in relation to air. Take a note, this defines, because this is somebody that asks to define, right? This defines the density of vapor in relation to air. So if you say hydrogen is denser than air, then it means hydrogen would actually settle like below oxygen. Then if you have like a cellar, a pit, a manhole, and you're testing to the top of that pit, you're testing for hydrogen sulfide. But you just put your hand down, you just put your hand and you're holding the meter there. But hydrogen sulfide is more denser than air there. So the meter may say, okay, well, it doesn't have hydrogen sulfide. But when somebody go in there now, if you have a like a H2S monitor, it may go off. But then you say, well, we tested it, we didn't get any H2S. But H2S is denser than air, denser than oxygen. So to test, you had to kind of go down, probably put on PPE or maybe send that monitor down there with some sort of retractable, mechanism to test that, right? Because it's denser than air, it's heavier than air. So the vapor, flammable, and combustible liquids can ignite if fires or sparks are present. The vapor density would indicate whether a gas is denser, greater than 1, or less dense, less than 1 than air. So density is actually out of 1. I don't know if you want to track down the formula for it. I think density is mass over volume, right? I do have somebody. You could just see if you could just take a note of that and track down the formula for the density. There's like a physics formula for it, which is not part of the course of the same, but there's like a physics formula for density, vapor density. Take a note of it that you may need to define it. And it doesn't take too much just to go and get it. I didn't see it in the book. I just saying that I know there's a physics definition for it, right? Let's go again. Vapor pressure is the pressure of a vapor in a thermodynamic equilibrium with its condensed phases in a closed system, right? all liquids and solids have a tendency to evaporate into a gaseous form, and all gases have a tendency to condense back to their liquid or solid form, right? So vapor pressure, I mean, simply put, is the pressure of the vapor in a system. Whatever it is, a pipeline, a scrubber, a manifold. Vapor pressure is the pressure of the vapor in the closed system, right? I can move on. So vapor pressure, the greater the vapor pressure, the easier it is for liquids to evaporate. A substance with a high vapor pressure at normal temperature is often referred to as volatile. For example, LPG and LNG, right? So LPG and LNG have a high vapor pressure, right? Meaning here they say it's easier for it, for a liquid to evaporate that, right? So we have I guess some test tubes here, some beakers and stuff. We have pure substance boil, vapor pressure due to pure substance, atmospheric pressure is acting on that. I don't think you have anything to draw a label like that. It's just a matter of defining. The greater the vapor pressure, the greater it is for the liquid to evaporate, right? So LPG and LNG have a high vapor pressure. Again, I'm thinking, if there could be any questions like that, it could be. Again, it's just to learn what you learn as the day goes along anyway. All right, definition, flammable. So a liquid that would ignite if it reaches its flash point and is provided with an ignition source. Flammable liquids have a flash point below 37.8 degrees Celsius and having a vapor pressure not exceeding 40 psi at absolute temperature and pressure and at 37.8 degrees Celsius shall be known as a class 1 liquid. These generally need to be heated before giving off an ignitable vapor, for example, diesel, paraffin, oils, etc. Right? Flammability limits are the limits between which the proportion of combustible gases in a mixture with air or oxygen is flammable. Gas mixtures consisting of combustible, oxidizing, and inert gases are only flammable under certain conditions. And these are the two limits you saw that they wanted to define. The upper flammability limit gives the richest flammable mixture. Beyond this, there is too much vapor and not enough air for ignition to take place. Right? Remember, that's the upper flammability limit. Once you cross that, you're going to get what is called like enrichment. Right? The lower flammability limit describes the leanest or the smallest quantity of mixture that can sustain a flame, i.e., the mixture with the smallest fraction of combustible gas. Below this, there is too much air and not enough vapor for the ignition to take place. So you want to kind of see if you can do something with these, right, to the best of your ability anyway. Controlling the risk, controlling gas and vapor concentration outside the explosive limit, sometimes referred to as gas freezing, is a major consideration in the oil and gas industry, particularly when introducing hot work or electrics to a possible flammable atmosphere. Gas freezing is normally achieved by natural and forced ventilation, supported as appropriate by cleaning techniques, for example, steam cleaning, water washing, etc. Toxicity, right? Toxicity is the degree to which a substance is able to damage and expose organisms. So that's a definition. Toxicity can be referred to the effect on the whole organism, such as an animal, bacterium, or plant, as well as the effect on a substructure of the organism, such as like a particular organ, right? Such as cell one organ, the liver, for example, right? So certain chemicals could affect the skin. The skin is an organ. Certain chemicals could affect, the respiratory system. If it is an asphyxiant, can make you cough. Certain could affect the bloodstream, like lead, right? So there are mainly three types of toxic entities: chemical, biological, and physical. Physical there is not what you think. Physical is not you. Physical here is meant for a group of terms that are called physical agents. And physical agents have to include things like light, radiation. Radiation is not chemical or biological, but it is physical. You want to take those two examples now? There's a group of harm out there then called physical agents. And it's not chemical, it's not a chemical we're talking about. We're talking about things like radiation. Right? You can take radiation as one good example here though. I need to drink some water, right? But remember, there are more about the definition. So toxicity is the degree to which a substance is able to damage and expose organism. Like radiation then. You're going for chemotherapy, God forbid, or some NDT testing you were doing, but that could affect your, your cells. Then radiation affect, like your cells. It could affect, for those of us who know radiation effects, like somatic cells, which is, like effects to you, and then it could affect your reproductive cells. Yeah, radiation could affect your reproductive cells. That's why it's called radiation. The effects could be seen in you, but could cause a lump, right? Radiation could cause some sort of harm to you, right? Okay, let's move on. Skin irritant. Irritation is a state of inflammation or painful reaction to allergy or cell lining damage. A stimulus or agent which induces a state of irritation is called an irritant. Irritant can be chemical agents, but also mechanical, for example, fiberglass. Thermal, heat, and radioactive stimuli, for example, ultraviolet light or ionizing radiation can also be irritants, right? Well, anyway, I won't talk too much. Ionizing radiation is bad. Ionizing radiation, if you're not too sure what that's the harmful kind of radiation. If you want to make a little note, ionizing radiation is alpha, beta, and gamma, right? Alpha, beta, and gamma radiation. If you don't think that's bad, just remember the Incredible Hulk. The Incredible Hulk was exposed to gamma radiation and came out the Incredible Hulk, right? But alpha and beta radiation can affect the skin. I don't know if you all know that. Alpha radiation can be stopped by your skin. Alpha radiation is not very penetrating. Alpha and beta is not very penetrating, but when it penetrates, it's very harmful, which is why the ability to penetrate is not representative of how harmful it is then, right? Alpha radiation could be stopped with a sheet of paper. One sheet of paper could stop alpha radiation. But if it gets into your body, it will affect, like your cells. It causes serious harm then, right? So the long and short of that is ionizing radiation is the harmful kind of radiation. Is there a good kind of radiation? Yes, maybe, right? Your cell phone uses radiation. That could be seen there. I mean, it could be harmful, but we use it for a lot of good reasons. The microwave. Microwave? I mean, other than the microwave being a piece of equipment, but microwave is not, the word microwave doesn't really, like everybody said the microwave. We're gonna hot the food in the microwave. But microwave is not really a piece of equipment. Microwave is a type of radiation. Yeah, X-rays are harmful as well, right? Of course, we use them for the right reasons, right? We use them to see, through skin and flesh, and we see the bone, right? But there are work activities like non-destructive testing that could expose someone to radiation in the hospital environment as well. Could expose, nurses and trainees and even patients to harmful forms of radiation, right? Anyway, the point of that there is that some types of radiation could affect you really bad, like your cells, but the head and the skin irritation. So I'm going to kind of stick to alpha and beta because that could just be stopped with one sheet of paper, right? I'm going to leave it right there that yes, radiation is harmful, but some forms of them are very harmful if they get into your skin, but the skin could actually stop some of them and it may cause a bit of irritation, skin burns or whatever have you. But yeah, the skin, could also be that layer anyway, right? Okay, so here we have carcinogens, a substance that is capable of altering the genetic material of an organism, leading to abnormal growth of tissue cells that can become cancerous with resulting tumors. So that's a big definition of carcinogen, right? I think you get the mark if you say, well, it alters your genetic material. That's where you get the mark. You want to know where you don't get the mark? You want to know where you don't get the mark? Well, you don't get the mark if you don't study this, right? But you don't get the mark if you say, they ask you what is a carcinogen, and you say a carcinogen causes cancer. They don't give the mark for that. You see, that's the effect. That's not the definition. So learn the definition, right? And you don't have to learn the whole thing, people. That's how they say a carcinogen affects your genetic material. It causes a change in your genetic material, right? If you remember the all of it, fine. But that's what you're looking for. It alters the genetic material. You all know what that means, right? It's too long to explain. Some of y'all, those who may have done like biology and stuff before in school, you know it, right? You know that everybody, how much chromosomes you have? That sounds like a Daniel question, a Daniel Loveless question. Anybody know how much chromosomes you have? Everybody sitting here today, how much chromosomes you have? I'll give you a clue, it's not a big amount, but on it have a lot of genes, so you have a lot of genes. But the chromosomes themselves, the chromosomes is like it's like what makes up like your cell structure there. It's like how much chromosomes in your body. Don't know if you know the answer for that, right? Anyway, you don't have to. I'm just saying that I'm trying to give you the idea that if that amount was affected, anybody know the answer for that? How much chromosomes you have? Nobody, nobody, nobody. Well, when you say altered genetic, you have 46. Anybody remember that? 23 comes from your father. 23 comes from your mother, right? So there's an equal contribution here between male and female to create you, right? And you have 46 chromosomes. If you check it, we get 46. Now, carcinogens affect that. If you have one less, guess what happens? If you have one more, if you have more than one less, you really don't live anyway. But it have people with one less and one more. They have one more chromosome. If you don't know what a chromosome, I told you a chromosome is like your body fiber. It's like the fiber of your being. And on this have different genes. It have the genes here for your eye color. It have the genes here for your skin, right? It have the genes here for your height. Some people say the genes for intelligence, but intelligence can be learned, right? But so there's a lot of genes on your chromosomes, right? But you have 46 chromosomes that makes up, that is replicated in your body there. There's a 46 types there, right? But I was saying, anybody know what happens if you have like if it is altered, if a carcinogen did alter it, if
They
a
become Down
carcinogen
syndrome.
altered, very good, right? What would happen? You wouldn't be too off, but you would have what is called Down syndrome, right? And that doesn't mean anything wrong because folks with Down syndrome, they would hear one tune and they can play, like a piece of Mozart or something that I cannot even do, right? And so, but the thing is like you wouldn't look the normal human way then, right? You look a bit different if you have if they alter your genetic material, right? So other examples of carcinogens in the workplace include inhaled asbestos. So much as say the inhaled asbestos doesn't come out of your system. Asbestos is not natural, it's like a man-made fiber. If you inhale it, if you say inhale, there's a type of it called inhalable. There's actually one type called respirable. If it gets into your lungs, then it doesn't come out. It stays there and it develops into a cancer. There's a long biology to it, right? Which is if a piece of it stays there, your blood cells, your white blood cells, you try to eat it. Because it's not organic, the cells are going to die. And then that's going to result in a lump, right? In your lungs. Yes, that's how it happens, right? Anyway, moving on. Certain dioxins and tobacco smoke, right? This is the global symbol for carcinogen if you all are seeing it for the first time. 2015, the world adopted some new science. If you all have never seen this before, it's probably because you didn't check it out. I have stretched it a bit. It's looking stretched. It's kind of more diamond. It's more diamond rather than a stretched diamond. And this is called a global harmonized system for carcinogens. And this sign actually means it's harmful to the respiratory system and stuff as well, right? The same symbol is used for that, right? If you want to see all of those signs, you could just Google them, the GHS symbols. Those are the symbols we use in the world today. You may have been familiar with the skull and bones and some of them, but the skull and bones is still around. But you do have some new labels coming out of the global harmonized system anyway, right? Moving along slowly. You see, it's not just a reader, it's to explain. Okay, well, this is finished, thank God, right? So that's finished. So all I would do there is tell you, well, you also from the past paper, some of them being important. I would say don't overlook anything when you get your book. Try to learn a definition for vapor density. Vapor density is, a measure of how heavier a gas is than air. Vapor pressure is the pressure of the condensate, like within a vessel. Hence, it's called vapor pressure. It's the pressure of the condensate, whatever you're looking at, whatever gas, even if it's air gas, right? In a chamber, in a line, in a tank, in a vat, right? In a silo, if the silo was enclosed, right? But it's the pressure within that confined space then, or within that space in the vessel itself, right? Let's move on. I actually haven't taken a look at the time. to see what time it is, but I suppose it may be about after 2, which is correct, right? So properties and hazards of gases, right? So this part of the course, if you want to run through a couple of gases and looking at the time, I think we could just read these. I don't see any problem with them, right? I don't see like an explanation too much, and it's like it's just what it is, right? So here we have hydrogen is a colorless, odorless, tasteless, flammable, and non-toxic gas. And it is the lightest of all gases. Hazards can include the hazards of hydrogen. Hydrogen is flammable over a wide range of concentration. The lower flammability limit is 4%, and the higher flammability limit is 75%. The ignition energy for hydrogen is very low. This means it can ignite even with very low energy sparks. Liquid hydrogen is extremely cool and can cause frostbite and cold burns. It can be an asphyxiant. Asphyxiant means it's difficult to breathe if that gas is present, and it's pure oxygen-free form. A hydrogen leak can rapidly become a large flammable vapor cloud. But I don't know if you know that most of us may have heard about hydrogen, the hydrogen bomb. So you can associate it with that. Hydrogen is flammable and it's very explosive, right? Anybody ever, you ever burst carbide? Anybody ever burst carbide for Diwali? Anybody ever tried a hand at carbide? You know what carbide is, right? Those of us in Trinidad. Somebody? You know what I'm talking about? Carbide that they put in like you can put it in a bamboo if you want. Some people put it like in an old pitch oil tin. Anybody ever had the experience of bursting carbide? No? Somebody said no. Anybody said, yeah, you all know what I'm talking about? Carbide. So carbide is actually calcium and a mixture of hydrogen, right?
I think
You
that's
can get
our
it in,
generation,
say it again.
Samuel.
Say it again, huh?
I think that's our generation.
Nah, man, people, but now if you know to burst bamboo, you must know about carbide. Anyway, if you have carbide, you can get it in the hardware. carbide, carbide, right? Hunters use it if anybody ever still do those kind of things. But if you have carbide, if you put it in a vessel, like a pitcher tin or something like a pan, like if you have a pan and you put a bit of water in it, because what happened, the water, which is hydrogen, water is H2O, and the carbide reacts, right? So normally what they do, they put the cover back on the pan, you put a little hole to the end of the container, and you put like a lighted stick there, which is what they do around Diwali time if you're bursting bamboo, and this creates a very loud explosion. But the point of that story is that what is actually happening there is that the carbide, when you add the water, it is reacting with the water to produce hydrogen, and hydrogen is explosive in that sense then. And a little bit of it, just a couple of drops of water, you'll see it reacting, and you cover that down, and that creates a loud explosion, louder than bamboo. And a lot of people actually put it, some people put it in the bamboo, but that may cause a bamboo to split. For those of us who know what I'm talking about, the pan and stuff is the best thing anyway. Right? Anyway, Diwali is coming up. I don't know if that's legal. And of course, if it's legal, don't do it anyway. I'm just telling you a story, right? So methane is naturally occurring combustible gas that is colorless and odorless. Methane is a primary component of natural gas. Methane, of course, is CH4. 94% by volume of natural gas is methane. Methane comes from a number of different sources. Underground deposits around the world of natural gas are the primary source of methane. Methane is also trapped in pockets near coal deposits, which, as I said, around the world. Methane can also be stored in liquid form, which is only flammable under high atmospheric pressure. This is actually the chemical representation of methane. It's 1 carbon and 4 hydrogens, 1, 2, 3, 4. Let's move on. Methane is extremely flammable in the presence of oxygen. The lower and upper flammability limits are there. Inhaling methane can be life-threatening because it causes asphyxiation by displacing the surrounding oxygen. Methane reacts violently with oxidizers, which is anything that produces oxygen, halogens, and halogen-containing compounds. So around the world, in the polar countries, you'll see methane is found naturally in various deposits. impermeable solid methane hydrate embedded in the mud. You normally find this, like I said, in Canada, wherever it's cool, of course, and including New York again. But places around the world, like Europe, right, have a lot of what we call marshes, if you make out that word anyway here, where you have methane naturally occurring there. There have been explosions. There was actually one a time in a car basement. Methane actually is naturally occurring in some parts of the world, in some countries of the world. It's in the ground, and if you have like a basement layer, which is like a multi-layer car park, methane could accumulate in that anyway, right? All right, LPG, liquid petroleum gas. So produce some petroleum. LPG is a mixture of gases, propane and butane. Its uses include fuel for cooking, heating of vehicles, and as a refrigerant. It is a colorless, odorless gas and has an odorizing agent added for leak detection purposes. Hazards can include it is flammable, all right, and non-flammable in the liquid state though. Mixture of hydrocarbon gases, and you have the low and upper flammability limited there again, right? And let's move on. LPGs are approximately twice as heavy as air when in gas form and tend to sink to the lowest possible level and may accumulate in cellars, pits, drains until it finds an ignition source. So LPG then have a higher vapor density than air, if you want to put that into perspective, right? LPG is stored under pressure. On release, it reverts to its gaseous liquid. This is what you have in your homes, by the way. The gas become about 250 times its stored liquid volume, thereby creating a flammable vapor cloud. Well, if it does lead to an explosion, right? At very high concentration, when mixed with air, vapor is an anesthetic and subsequently an asphyxiant by diluting the available oxygen. LNG is liquefied natural gas. It originates from underground liquid oil and gas reservoirs, often discovered through drilling and exploration operation. LNG is principally used for transporting natural gas to markets where it is regasified and distributed as pipeline natural gas. LNG hazards. The gas is a liquid because it is stored at a very low temperature, minus 162 degrees Celsius, at around atmospheric pressure. Because of its temperature, LNG causes cold burns. Look at how cold it is, minus 162. At ambient temperatures, the liquid rapidly expands to 600 times the volume of its liquid form, forming an odorless and highly flammable gas, and they have the lower flammability and upper flammability limits there. I don't expect them to ask you those things, so please don't learn those things. Those things are not really, like exam questions anyway, right? LNG hazards may result in a pool fire. We could explain that a bit in a bit. Such fires are not possible to extinguish if there is a large spillage. The fire will be left to burn until all the LNG is consumed by the liquid. That is actually true, right? But those of us who did process safety, you probably know what a pool fire is. Those of us who didn't, a pool fire is not really a pool. A pool fire is just like the vapors are just in one place then. A pool fire is not a physical pool. The pool talks about like the fire is not spreading, it's just like within one confined area, right? So the word pool there doesn't really mean it's spilling a bond or a collection pit. It doesn't even mean that. Pool fire just mean, in fact, a pool fire is a fire that just burns. It doesn't have any real momentum. It's just going. It doesn't really, the fire is not under pressure then. It's not jetting out. It's just burning, and it's just burning and consuming itself then, right? It is not really limited to a pool, because what the situation here says is that it's the vapor that is confined. That's why it gets its name, pool fire, right? It burns in one particular area then, not really a physical area, right? I don't think they'll answer that. So I'm just trying to explain some obvious stuff there, right? Properties of and hazards of gases. We have hydrogen sulfide on this slide. So found in crude oil and gas, hydrogen sulfide is considered a broad spectrum poison, meaning it can poison several different systems in the body. Although the nervous system and respiratory system are most affected. Besides being highly toxic, hydrogen sulfide is a flammable gas. It also causes irritation to the eyes, skin, and mucous membrane. Further hazards, right? So this skull and bone thing up there, right? What I told you was a sign for, like the signs used around the world. This would have changed though, because it would have been changed to the diamond. The same skull and bone is used, but the borders around the skull and bone is actually now a diamond, right? So we have hydrogen sulfide again, so highly toxic and extremely low concentration, that is hydrogen sulfide. At concentrations of 800 parts per million, 50% of the people will die within 5 minutes of exposure. To just fact it, this is not for exam. At 1,000 parts per million, right, will cause instant collapse and loss of breathing, even with one single breath. Toxic and a fire explosion risk if it finds an ignition source. It has an extremely pungent odor, the smell of rotten eggs, but rapidly destroy the sense of smell due to its corrosiveness. This means that potential victims may be unaware of the danger. It can be smelled by humans at concentration as low as 0.00047%. Just information, right? Whatever you want to learn, you learn anyway. Oxygen. I'll go a little bit faster this because we're supposed to know enrichment and deficiency. If not, it's on the slide. You just saw enrichment here. Deficiency would be anything, wrong, less than 19.5, right? So the air we breathe in contains about 21% of oxygen. Without oxygen, we will die in a matter of minutes. However, oxygen can also be dangerous. The dangers are fires and explosion. Oxygen behaves differently to air. Compressed air, nitrogen, and other inert gases. It is very reactive. Pure oxygen at high pressure, such as from a cylinder, can react violently with common materials such as oil and grease. Other materials may catch fire spontaneously. Nearly all materials, including textile, rubber, and even metal, will burn vigorously in oxygen. Oxygen again. A small increase in oxygen levels in the air to 23% oxygen enrichment can create a dangerous situation. It becomes easier to start a fire, which will then burn hotter and more fiercely than in normal air. It may be almost impossible to put out the fire. A leaking valve or hose in a poorly ventilated room or confined space can quickly increase the oxygen concentration to a dangerous level. For example, the HMS Glasgow incident in 1976. This is actually a ship, by the way, a vessel, a ship, right? Yeah, anti-foaming. You can check it up a bit. Like I said, I would try to put my videos in slowly but surely, but I don't think they're gonna go into that way, right? To have you discuss types of accidents, especially some of the HMS Glasgow, when you have more popular accidents like Palpa Alpha over there anyway, right? Additives, I have 10 minutes again. I'm gonna try to push as much as I could. Additives. So we have anti-foaming. This is common sense, right? A defoamer or an anti-foaming agent is a chemical additive that reduces and hinders the formation of foam in the industrial process liquids. An essential feature is a low viscosity and a facility to spread rapidly on foamy surfaces. So like if you put this, it wouldn't have a foam then, right? It has affinity to the air liquid surface where it destabilizes the foam. Anti-foaming agents may be oil, powder, water, or silicone based. It have a picture of one here. Hazards associated with anti-foaming agents generally concern skin or eye irritation, right? So this, is used like in the oil and gas industry. We want to protect your equipment, anti-foaming agents being tested on foam here. So once you add it, then it's going to get rid of the foam. It's going to get rid of any but in this case, additive that may have caused corrosion or lingered onto your metal surfaces. If you think about offshore equipment and stuff being, placed in water all the time, right? They would have had to be, treated, and perhaps maybe one of which, based on a risk assessment, would have been, like an anti-foaming agent, right? Same thing for anti-wetting agents. Water is often detrimental to materials when their surface become penetrated by moisture. Metal surfaces can corrode and would degrade, so you want to coat it, right? Anti-foaming, anti-wetting. So anti-wetting agents, for example, Teflon places a waterproof barrier between the surface of the material and the water, for example, seawater and rain. So you want to kind of have your equipment that is in a wet condition. If it's a scrubber, if you don't know what that is, if it's some sort of condenser, right? You may want to have it treated to kind of prevent rust forming on it, and you can go with an anti-wetting, anti-foaming agent based on what chemicals you were exposed to, of course, right? Such coatings are said to be hydrophobic, meaning that it repels water. Anti-wetting agents effectively offer good corrosion protection. There's a picture of one with the anti-wetting agent, and you see the liquid. It's kind of like a dashing leaf. For those of us who know that is what a tarot leaf, if you don't call it dashing in Guyana, right? Like where, like when rain falls and you can actually see the water droplets, so you can say that that plant, the tarot plant and the dashing plant, have a natural anti-wetting property then to the leaf then, right? But that same principle is used in the oil and gas industry to protect surfaces of materials. Somebody had a question?
Yes, sir. Excuse. Unfortunately, I had to leave early. I know we are
No
calling
problem. I'll put your present still. Yeah. Yeah. Well, we
Absolutely.
almost finished. I only go in 5 minutes again.
Okay,
We
no
have
problem.
another class after this one here. All right.
All right, cool.
All
Have a
right.
good day.
Yeah, let me see if I can wrap up biocide, and maybe we could probably do here what I wouldn't want to race down everything. So we could finish refrigerant and we'll stop right here. Hazardous properties of water. Or no, here what I want to finish up that and I'll stop here. Because here the topic changes, right? All of these would have just been, hazards in the oil and gas field then, right? Like hydrogen sulfide, LPG. But hazards of steam, we can stop there and I'll take that off on Wednesday evening. Let me just read all these, and I wouldn't stop to explain. I'll just read. I'll do probably one explanation at the end, right? So the one here, the topic of concern here is properties of hazards of associated products and control measures. They have microbiocides. Microbiocides are used in the gas and oil industry to control the growth of bacteria and prevent the formation of harmful byproducts of their growth, such as hydrogen sulfide. A biocide is a chemical substance or microorganism. Yes, they could be an organism. Despite the name biocide, does not actually have to kill. It may instead deter, render harmless, prevent the action of an otherwise exert a controlling effect on any harmful organism by chemical or biological means. Yes, we have bacteria that does this, by the way, right? We did not get, right? Can be added to protect materials, typically liquids, against biological infestation and growth. In refineries, for example, uses include the treatment of cooling water to remove and prevent spores, fungi, Legionella bacteria, which affects your lungs, right? And to prevent bacterial slime, which significantly reduce heat transfer in cooling systems, such as heat exchangers, right? Here we have pictures of bacteria and spores. Corrosion prevention. These are additives which are used to delay or prevent the formation of corrosion within vessels, pipelines, and structures. And if you find it reading a little bit louder, it's because the rain is actually down, right? So normally I hear it. I know you all can't hear it, but I hear it anyway, right? Because it's on the road. A refrigerant is a substance used to provide cooling, either as the working substance of a refrigerator or by direct absorption of heat. Common refrigerants include ammonia, sulfur dioxide, and propane. Health risks include flammability of those refrigerants, toxicity of those refrigerants, and cold burns. At high levels, they can cause central nervous system depression and cardiac arrest. Vapor displaces air and can cause asphyxiation. Vapor displaces the air, so it results in being difficult to breathe in, right, in confined spaces. The last slide for today, and I'll call the roll after this, is that water exists in three states: solid, liquid, ice, of course, solid, and gas, steam. It is used extensively in the oil and gas industry processes. Uses include for water, cooling, lubrication, for example, for drilling mud. Drilling mud is what we call sludge, or some version of sludge, or LSAs. We'll look at that on Wednesday. Fire, water source, right? So water is a source of, water is a source. In the case of a fire, you have the water available, right? Steam, power turbines to generate electric power, to drive pumps, compressors, fans, and other equipment is a use of water. Heating source, control rooms, tank coils, and trace heating would actually use water as a cooling agent, or in this case, steam as a heating agent, for those coils anyway, right? We'll stop it right here. We're going to look at, on Wednesday, the properties of hazards and steam. I definitely know I didn't reach where I wanted to reach, but that's because class is not always a reading exercise. It's often, my mistake is often, it's often, a more of an explanation thing anyway, right? Let me see so I think we got to about slide 58, 59. That wasn't too bad. I had a slide 70 in mind. That wasn't too bad. So I know we could kind of play catch up with that on Wednesday, right? Just to make it the rule, I'm going to stop the recording. For those who know, we don't really call the recording air for confidential reasons.